So this lesson is going to be a lot of conceptual stuff. So the notes aren't huge, but I would recommend that you write down your some of the definitions and things like that. This is, last we were talking about. Last unit we were talking about. Sorry, I just totally lost my train of thought. Okay, last unit we were talking about confidence intervals, and this unit we're going to talk about hypothesis testing, which means we're actually going to run experiments and talk about whether we can prove that something is statistically different from something else. Now, here's the thing with statistical hypotheses. We make this as a statistical hypothesis, a conjecture about a population parameter. Okay, that means that we're going to make a guess. All right, we think that the population parameter is not the same, or is we think that our statistics or our experiment will prove something different than's already established. So now, so you're going to have two hypotheses. We're going to have a null hypothesis and an alternative hypothesis. Now, this is H1. You will see this written as H1 or HA for alternative. You usually will start with the alternative hypothesis because that's what you want to have happen. Okay? The null hypothesis is what we don't want to have happen, or what is true if what we say, if what we decide, what we guess is not true. So your goal is to prove that the null hypothesis is false. Okay, we can never say for sure that our hypothesis is correct, but we can prove that the null hypothesis is false. I know that sounds very bizarre, but that's what we're doing. We're showing that the null hypothesis is false. So to do this, we're going to run certain tests. Now, let's get this over here to the side. Okay. So again, lots of conceptual stuff. These are the kind of things I want you to write down so that you make sure you have them. So we're either going to run a two-tailed test, a right-tailed test, or a left-tailed test. If you remember on the T-chart, we saw information about these tests. So the T-chart will help us with the data or with the t-values or z-values that we need. So we're either going to prove that something is not that the mean that we will find is not going to be the same as the population mean. The mean that we find is going to be greater than the population mean, or the mean that we find is going to be less than the mean that we have, or the mean is going to be great, or our mean is going to be greater than the population mean. So these are the three things that we're going to try to prove. The null hypothesis is what we don't want to have happen. So we usually will write our alternative hypotheses first, and then reflect that in the null hypothesis. These symbols right here are symbols you need to make sure that you know. The equal sign, the not equal sign, greater than, less than, greater than or equal to, or less than or equal to. And down here are words that might symbolize those different things. So you don't necessarily need to write all of those down. It's in your book if you want to use it as a reference. That's usually a good reference. So, okay, moving on. I moved stuff up so we could see it all. So a lot of this is about words and being able to interpret it. This section is all about writing hypotheses. We're not actually going to do any calculating in this section. So here we have, this is example 1, so please make sure that you write this down as example 1. The situations, you can abbreviate. You don't necessarily have to write the whole words, okay? Write some, though, so you have a reference to them. So situation A says, a medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? So we have to think for a minute about what is it asking, okay? Is it asking us to prove that something is greater than, less than, or just simply different than what the normal value would be? And in this case, it's going to be simply different. So our alternative hypotheses, hopefully I wrote it here quickly. I wrote it on here. Where'd it go? Did I get distracted while I was recording the video? Perhaps. Okay. So the H0 is that the mean will stay the same. Okay? And the H1 is that the mean will be different. So this is all we're saying is that the value that we find will be different than the value that we're given. So So this is important. Now this one, notice there's no numbers. You will almost always have numbers, okay? So so that you need numbers in order to be able to run an experiment or a test. So moving on to situation B. A chemist invents an additive to increase the life of an automobile battery. If the mean lifetime of the automobile battery without the additive is 36 months, then her hypotheses are, okay? So we want to say that it wants to be greater than 36 months. So in this case, I wrote them backwards. I should have started with H1. You will always see H0 written first, but when you're actually finding it, you will usually find the H1 first because that's what you're looking for. So I want to say that the mean lifetime is greater than 36 months. So my hypotheses, or my alternative hypotheses, that mean will be greater than 36 months. My H0, or my null hypothesis, is that it will be less than or equal to. So, and then situation C says, a contractor wishes to lower heating bills by using a special type of insulation in the houses. If an average monthly heating bill is $78, hypotheses about heating costs with the use of insulation are, okay, so my H0 is going to be the opposite of what I want, okay, that the mean will be greater than or equal to 78, and my H1 is what I want, which is that the mean will be less than 78. Okay, if we go back to, and I'm not going to scroll back on the video, but if we go back to that screen that had the 3 different hypotheses on it, once you write your H1, you can the H0 will be the opposite of it. I also think I said it backwards when I was talking about the values. I can't remember now, but back there I probably did. Okay, so moving on to your practice. Okay, so these are your practice problems. I want you to try these on your own, see if you could write hypotheses, and then we will go over the solutions. So go ahead and pause the video, do your practice. Okay, so here are our solutions. Part A says, a researcher thinks that if an expectant mother uses vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. So my H1 here is that the mean will be greater than 8.6. And then my H0 is the opposite of that, less than or equal to. All right. B says, an engineer hypotheses that a mean number of defects can be decreased in the manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defects per disc is 18, per 1,000 discs is 18. So we want to say that the robots can be is going to be less than the human rate. So our H1 is that the mean is less than 18. Our H0 then is that the mean would be greater than or equal to 18. Okay. C, a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, there was a mean score of 73. So this is just, we don't know. We think it'll be different, but we don't know what the effect is going to be. So our H1 is that the mean will be different than 73. Our H0 is that the mean will be the same. Now I will say this, 9 times out of 10, you are going to be a greater than or equal to situation, not an equals or not equals to. You're usually saying, I think it's going to be better than, or I think it's going to be worse than, which are one-tailed tests, which are easier to deal with than two-tailed tests. So realize anytime you have an equals and a not equals to, it's a little more difficult to deal with. You may want to think about that as you think about your own project and study as well. Okay, I think this is it. Oh, okay, errors. Okay, so more conceptual stuff. Like this was really heavy on the concepts. So a statistical test is using the data that we obtain from a sample. So we'll create a sample and we're going to run a test. And there's 2 types of errors that we can make. So we have our hypotheses, and we could make either a type 1 error or a type 2 error. So once we run the test and we use the statistical value, if we reject H0, but H0 is true, we have made a type 1 error. If we don't reject H0 and H0 is false, we've made a type 2 error. Okay, so we're going to use these errors in saying, okay, what are the percentage of error that I might have? And this is where those numbers come from. There's tons of vocabulary in this section. So, so first of all, the level of significance of a type 1 error, okay, that is the one if we reject H0, but H0 is still true, okay. A type 1 error is the maximum probability of committing that error is going to be alpha. So if you remember, we talked about alphas during confidence interval. Okay, alpha was usually 0.05. It could be 0.1 or 0.11, but usually it was 0.05, which had a z-score of 1.96. Okay, so a one-tailed test is when we have a greater than or less than situation. A two-tailed test is if we have, what did I name for that on there? Is if we have just not equals to. All right, critical value. Now, this is where, and we're going to talk more about this in the next lesson, but a critical value is where is saying that that anything above or below this value, depending on whether we have a greater than or less than symbol, will go ahead and give us the answers that we want. So it's a rejection region. It's saying if we find that a value, let's say our critical value is 1.96 for 95%, and the number that we calculated when we ran our test was 2.0, that's greater than 1.96, which means that we can reject our null hypothesis, which is actually what we want. I know this sounds a little confusing right now. We're just dealing with vocabulary. We'll use this more next time. But if our value were less than 1.96, say 1.5, we would not be able to reject, and therefore we would not be able to say anything about our data as far as it being true. So this right here gives us critical regions, and it shows us, and it gives us for all these different tests the critical values. So these are important, and you're going to want to write these down. For left-tailed, right-tailed, and two-tailed, this is also, you don't necessarily, I guess you don't have to write them down. They're also in your T-charts, which you will have, the ones on the bottom. So if you have a left-tailed test, a right-tailed test, or a two-tailed test. So for a left-tailed test, these are our critical values, and for us to be able to reject the null hypotheses, which is what we want to do, the values have to be less than these numbers. So if it's alpha equals 10%, it has to be less than 1.28. If alpha equals 0.05, it has to be less than negative 1.65. And if it's alpha 01, it needs to be less than negative 2.33. The right-tailed test is just the opposite. It has to be greater than those values. And a two-tailed test, the numbers are bigger because we have to split the region in half. So 1.65, 1.96, and 2.58. These numbers look really familiar because in confidence intervals, we were always two-tailed. We were looking at two sides. So, and confidence intervals actually are almost exactly the same as a two-tailed test. We just never said for sure. We would say we were 95% confident that our mean fell within those two values. So now we're looking at what happens when our mean falls outside of those values. And that is the end of the lesson today. I know there was really only one example, but it was a lot of vocabulary. So.